Welcome to clickmyproject.com. Our product title is Design of Approximate Radix-4 Booth Multipliers for Error Tolerance Computing. Now we are going to discuss about our product abstract. The approximate booth multipliers are designed based on the Xilinx VHDL language. The approximate Radix-4 is a booth encoding the current design of the multiplier can be the truncation model of the simple approximation model. This low part of the partial product, the least significant partial product, is the estimate by the constant value for the multiplier's input. Here, more efficient than the approximate Radix-4 multipliers encoded, so present on the some extensively analyzed part of the approximator and both multipliers. Here, we are going to the proposed the regulation of the approximate multipliers. So, the factor of force assistance for the designing the both multipliers can be extensively evaluated for the error analysis, and the proposed the multipliers for the can be applied for the application in the image processing. Here the consist of the three part of the both multipliers: the partial product generations using the both encoders, and partial product accumulator using the compression values, and the final product generation for the based on the and the final product generation using the first adder. Here the most important for the approximate Radix-4 for both encoding process to complement of the multiplications and design based for the encoding the process. Here the approximate partial product arrays we generate for the some both encoding and then product addition for the each and every input for the regulation approximate arrays. Here the improving the performance and implementation for the two's complement binary numbers, improve the some modify both encoding algorithm. Here the encoding plays important for the multiplying the reduce the number of the partial product row of the constant of the value efficiency. The approximate 4 and encoding level is carefully considered for the some sequence of the input bits. Finally, after we design the product array and error approximate the adder, some distance based we have normalized for the both multipliers. Now we are going to discuss about our product flow diagram. In our process, we have given the input data bits for the 12-bit input data, and then we are going to the encoding the process. We have determined the three part of the both multipliers. First, the partially product generations. It's mean the encoding the process. The partial product encoding the having the radix for both multipliers. Here we have implement for that two's complement of the multiplication. We have using the interface for the half adder and full adder process, having the k map value based 2-bit and 4-bit level of the multiplication. And then we have encoding the process has two level of the partial product accumulator and final product generations. Here the main part of the both multipliers consider that product generations. Using the both encoding the process, we have determined the D registers architectures. Here we implement that 2 by 2 we have column based, we have stage 1 and 2 based, we have step up the register based, we have going to the multiplications. After we go into the array formation of the RAM positions. Here we implemented the where we going to the store the data in which we getting from the read and write operations for the partial product array formation. And lastly we go into the error corrections operation block. Here we have wherever we go into the multiplications in occur the error, we are just going to that array encoding the process, going to the some distance based on calculate the distance, we are getting the find the occur the error for process. So finally we go into the analysis synthesis report for the multiplications for the 8-bit and 12-bit radix both multiplications, and power area and schematic diagram and LUTs levels and the speed levels, frequency levels. So we are going to the implementation and we get analysis the best result and improve the based on the some systems process. Now we are going to discuss about our product running procedure. In our process, the 8 Radix-4 both multiplier have using the VSTL language in Xilinx 14.2 versions software tool. Now we have implementation and the coding completed. After we go into the simulation part and implementation result. So simulation process we are going to the some graphically we are generated the binary waves based we are getting the output, and implementation result we are getting the schematic diagram and design summary based we are getting the some improvement of the results. So we are compared to the implementation result in the X system based we have manipulation calculated. First we are going to the simulation process. So this is the main coding. After we are going to that the first simulate behavioral model. So we getting the iSim simulator for the graphically waveform generated. This is the iSimulator based we have give them some binary inputs. So this is the A and B the input values data bits. So right click and we give the some force constant value, so binary value. So give the some 8-bit value. The same model for the B, the force constant value. Just to give the some clock value for the force clock. So leading edge value is 0 and trial edging value is 1 and period is 1000 nanosecond. So reset value for the we give the value for the 1. So everyone is completed to give the input and output is the P. 25-bit we get the output values for the multiplication output. So this is a simulation output for the Radix-4 both multipliers. Now we are going to for the implementation result. Here in the implementation, now we completed the simulation and now we are going to the implementation result. Oh, this is a main code and we are going to the synthesis XST process going to the run after getting the RTL schematic diagram. So now we go into the view the RTL schematic diagram. So multipliers, add the multipliers and create the schematic diagram. So this is our RTL schematic diagram based. So here we implementation for. So after we go into the forms design summary result for that. So overall RTL schematic diagram for the chip based we are using implementation. Now we go into the implementation result. Here we go into the implementation and run the process. We getting the number of areas and registers we are using the process. Design summary is going to the number of LUTs. So synthesis report and device utilization process. So this is our main process for the LUTs and lookup tables. So this is the main our device utilization summary based on the area and speed and process, and this is the delay functions bar for the process. So offset the delay for 4.40510 nanoseconds. So basically we are getting the delay timing process. So thank you for watching our video.